Welcome to Section 3 of Module 2, where we're now focusing on demand management and in-house production. Just to say one more time, this module is about conducting our own manufacturing activities based on the importation of raw materials. We're going to start off with some key definitions, very important definitions. We've talked about demand management already, but we're going to level set the conversation just one more time so we understand exactly what it is we're talking about. Demand management refers to the ongoing process of identifying and planning for all sources of product or service demand. Of course, we're dealing with products only here. Essentially, and we'll see this in a subsequent slide, demand management for us is about a sales forecast and then the receipt of actual customer orders, customers going into stores, customers placing orders online and such. That's what we mean by demand management. For in-house manufacturers, demand management forces a company to create trade-offs between demand, capacity, and the prioritization of production runs. We've talked about this as well. We estimate our demand through a forecast. We then start receiving customer orders. Either way, we're going to have a certain amount of production capacity. Hopefully, it's a good problem to have. We have more demand than we have capacity. We certainly wouldn't want it the other way around. But in that positive scenario, where we have lots of demand, we have to be able to prioritize our production runs, which means we have to manage the prioritization of the import of our raw materials. As we've seen previously, demand management basically encompasses 4 functional activities. We've talked a lot about forecasting. We'll continue to do that. We've talked a lot about the actual receipt of customer orders, what we refer to here as order management. In future modules, we'll talk more about available to promise, but that is essentially the allocation of finished goods to specific customer orders. And what we'll really get into shortly is the interface between the marketplace, sources of demand, and manufacturing planning and control activities, MP&C. All of the activities that encompass a true in-house manufacturing environment. We'll get into all of these in increasing amounts of detail. Here's something we haven't talked about too much at all. Independent versus dependent demand. And this relates to the forecasting of sales for finished goods. Super critical to make a distinction between the two. Independent demand refers to demand for a product that is not related to or driven by demand for another product. Really what we're talking about here is demand for finished goods, the goods that we make and sell in the marketplace. That demand is driven by our customers, and they are certainly independent of our organization. They can make their purchasing decisions based on a number of criteria. We have to influence and align with that criteria, but in the end, the demand for finished goods is external to the organization. When we forecast, we want to be forecasting for finished goods for independent demand. Moving along with that logic, second sub-bullet point, forecasts for finished goods drive dependent demand. Let's talk about that more in upcoming slides. When we think about independent demand, we want to be thinking about finished goods. When we think about dependent demand, we want to be thinking about raw materials, components, etc. Why is that? Because the items that go into a manufacturing process, those raw materials, the quantities that we're going to need are dependent upon the amount of finished goods that we're going to make. That's the relationship, independent versus dependent demand. Let's repeat that in our second bullet point. The amount of raw materials needed for manufacturing is dependent upon the amount of finished goods that will be produced. Dependent demand, almost always raw material. Independent demand, finished goods. Determinations of the needs around dependent demand are facilitated by what's referred to as the bill of materials for a finished good. Let's talk about that now. As we said, and want to reiterate here, supply chain professionals, we must always make a distinction between independent and dependent demand. One more time, independent demand, finished goods. Dependent demand, raw materials. The amount of raw materials that we are going to need to import is dependent upon the quantity of finished goods that we are going to make. What are we going to make? Depends on the forecast and actual demand signals. That's a good example of the linkages that we've been talking about so much. Second bullet, this point is especially true when companies do their own manufacturing in-house, which is exactly what we're talking about right now. We have to engage in these activities, the linking of independent and dependent demand. To summarize, forecasts for independent demand always dictate dependent demand. This is a process known as exploding the bill of material. We've heard about bills of material a couple of times now, BOMs as they're often called. Let's elaborate a bit on that. The definition of the bill of material. In simplistic but powerful terms, think of a bill of material, a BOM, as a recipe for making a specific product. What are we going to make? What are the ingredients that go into it? It is the same exact concept. Why is that? Because BOMs provide a listing of all raw materials, components, subassemblies that go into making a product. It's just like a recipe. Of equal importance, the BOM also quantifies the amount of each raw material that is required. What are we making? What goes into making it? And how much of each ingredient do we need? That's what a bill of material does. And on the right-hand side of this slide is a smaller version of what we'll see blown up in just one moment. It is a computer-based portrayal of a BOM. Continuing on with this discussion on the bill of material, a bill of material provides a visible link between dependent and independent demand, the relationship between a finished product and the raw materials that go into it. What are we going to make? What are the ingredients that go into it? And how much of each ingredient are we going to need? Continuing on with this sequence, combined with information on forecasts, current inventory levels, and lead times, bills of material help to drive the purchasing function for an in-house production model. Couple stops here on this particular bullet point. We've talked about forecasts. Put that to the side for a second. What do we mean by current inventory levels? Current inventory levels of raw materials. So a BOM tells us what we need and in what quantity, but we as production people also have to take into consideration, what do we have in raw materials already in inventory? That's going to influence the quantities and the timing of purchase orders that we place on overseas vendors for the raw materials that we use going into production. That's what we mean here. Essentially, what is referred to as material requirements planning. Once again, we have a whole module on MRP, so don't worry about the complexities of that just yet. We're talking about the BOM. Speaking of which, we have an example of a system-based bill of material, something found online, most likely in an enterprise resource planning module. Upper left-hand corner, we can see that this is indeed a bill of material. But what we're looking at is a master item tree. Just a breakdown of all of the ingredients that go into the recipe for making this product. Before we go into that tree, we'll identify our item number, 2505, on, but also on the right-hand side, we can see some fields for item specifications. The item type, the part number, etc. Our focus is more on the left-hand side because this is the recipe. What goes into making this item and in what quantities? And the way this system-based module is set up, we can click on various icons and break down into sub-assemblies, components. We won't do that here, but the capability is within the system. A very granular look at the recipe for a given product, a given item. We won't run through the whole thing, but let's illustrate a couple of points here. Look, for example, this recipe, this BOM, calls for a spring for a large pulley. Parenthetically 1, that tells us for every one of this item that we're going to make, we're going to need one spring for the large pulley that goes into the overall product. Moving down, we need some cotter pins, 2 of those, and nuts for threaded rods, 4 of those. What are the ingredients and what are the quantities that we need? That's what a BOM does. The BOM, along with forecasting quantities, as we said previously, current inventory levels of raw materials that we have already and the cumulative lead times from vendors overseas are going to determine the sequencing and the quantities of raw materials that we're going to buy. That is material requirements planning, full module upcoming. Let's wrap up this section with a supply chain perspective exploding the bill of material. What does that mean? The BOM is a helpful tool when trying to understand independent versus dependent demand. From previous discussions, we know that independent demand is driven by the finished product itself. Because BOMs list both the types and quantities of raw materials that go into a product, the BOM automatically reveals what the dependent demand is. That is the essence of the relationship between independent and dependent demand. As an example, consider a bakery that is preparing to bake a variety of pies for Thanksgiving. Essentially, each recipe is the BOM for a given pie, showing not only a list of ingredients, but what quantity of each that is required. For example, if the bakery knows that they're going to make 100 apple pies on Monday, of course, Thanksgiving is always on a Thursday, and each pie calls for 5 apples, then the total amount of apples required will be 500. That is exploding the BOM. But we have to do it for every ingredient that goes into our pies. Or, going back to our previous example, for the spring for the large pulley, we need 1. The cotter pins, we need 2. And the nuts for the threaded rods, we need 4. Either way, whether we're talking about a bakery or a real-world manufacturing environment that imports its raw materials, the above activity is referred to as exploding the BOM, and it is one of the most important functions for an in-house manufacturing operation. As we said, and will continue to say, combined with information from sales forecasts, actual customer orders, and production planning, explosion of a BOM is what drives key supply chain activities that include sourcing, purchasing, and inbound logistics. Purchasing of what? Raw materials in our case, and the inbound logistics that facilitates the movement of those imported raw materials. That's it for this section. When we come back, we move on to a big subject: manufacturing, planning, and control. We shall see you soon.